11.5. A formula for the volume of a rectangular prisms. The objective is to guide the development and use of a formula for finding the volume of a rectangular prism. Let's look at some mental math and reflexes. These should be coming to you almost automatic anymore. 6 plus 4, 20. 25 plus 5, 30. 11 plus 9, 20. 37 plus 3, 40. 18 plus 19, 37. 49 plus 17, 66. 48 plus 16, 64. 32 plus 18, 50. These are a little harder. 353 plus 29, 282. 149 plus 76, 225. 126 plus 259, 385. And 644 plus 39, 683. This is in Math Journal, page 298. So write a formula for the area of a rectangle. In your formula, use A for area. Use L and W for length and width, or B and H for base and height. So this is what it's asking. Here you see, let me back up to this. So area equals, that's what it told you, either length times width, or, and sorry for my handwriting with this, area equals base times height. So it's just the abbreviation, the first letter of those words. So look at the rectangle below. The sides are measuring 3 centimeters and 9 centimeters. So I need to find my area, not perimeter, area. Well, this is definitely the 3 centimeter side, and this would be the 9 centimeter side. So how would I figure that area? My number model would be 3 times 9 is going to equal my area. And I know my area because 3 times 9 is 27. So it's going to be 27 square centimeters. So find the height of the rectangle. Well, they're telling you that this is 7 meters. Okay, so I'm going to write down what I know. 7 meters. Times what? Times that question mark is going to equal the 56 meters squared. There's my squared symbol, that number 2. So now all I have to figure out is, what is the number that's missing? 7 times what gives me 56? Well, 7 times 8. Notice I didn't have to get out a ruler or my geo template and actually measure this. I'm just figuring the answer out. Let's look at the next one. This is telling me that, hey, you know what? This time you don't have the length of the base of the rectangle. So what times 12 is going to equal 84 inches, and again, squared. So 12 times what gives me 84? Well, because I know my math facts very well, I know 2 times something has to be something that ends in a 4, so I know 2 times 2 is 4, but that would only make this 24. So 7 times 2 is 14. So when I do the multiplication in my head, I do realize that 12 times 7 is 84. So my answer, my length of my base, is 7. Again, notice I did not have to get out any measuring tool to measure those actual lengths. Now before we go on with area, this would be a good time, I think, for you to figure out perimeter. Perimeter is when we're looking at the numbers around the outside of the box. So we have to make sure that we're adding, if there's 4 sides, 1, 2, 3. Sorry, this is not working very well this morning. And 4. I need 4 numbers to add. Well, so far I only have a 3 and a 9. But you should know, if this side is 9, then this side would be 9. And if this side is a 3, then this side is a 3. So I'm actually going to add for perimeter 3 plus 9 is 12, plus 9 is 21, plus 3 equals 24. That's perimeter. Again, perimeter for here. If this side is 7, then this side is 7. If we figured out that this side is 8, and we know that because we figured it out below, that this side is 8. So I'm plussing 7 plus 8 is 15, plus again 15 is 30. So the perimeter of this shape would be 30. And finally this last one. If this side is 12, this side would be 12. We figured out this side was 7, then this side needs to be 7. So 12 plus 12 is 24, plus 7 is 31, plus 7 is 38. So this is 38 for the perimeter. I just want you to see the difference between area and perimeter. Go ahead and do the try this on the bottom by yourself and then correct it in the math journal answer key. 11.5. And remember, you can always use your SRB, and it's telling you that you can go to page 138. So it says each picture at the bottom of this page and on the next page shows a box that is partially filled with cubes. The cubes in each box are the same size, and each box has at least one stack of cubes that goes to the top. Your task is to find the total number of cubes needed to completely fill each box. And then we're going to record your answers in the table. So, how many cubes can be placed along the longer side of the box? So we're looking at box 1 here. How many cubes can be placed along the longer side? 8. Let's look at that. 1, 2, 3, 4, 5. There should be one here. And one here. 6. One here. 7. And one here. 8. How about along the shorter side? You should see 4. Let's count. Well, this would be 1. Here's 2, going back, 3 going back, 4 going back. So how many cubes are needed to cover the bottom of the box? What I would do is I would take 8 times 4, because I got to fill this all up. I'm trying to fill up this entire area here. So I would take 8 times 4 is 32. Whoops. How many layers of cubes are needed to fill the box in number 2? Oh, I'm sorry, to fill the box in number 1. Well, now I would have to take, and it's showing you 5 goes up. So here we go. 1, 2, 3, 4, 5. So I'm going to take that 32 times 5, and it's going to take a total of 160. There are 5 cubes in this stack to fill the box. There are 5 layers with 32 cubes, so I got to do 5 times 32, which is 160. So we would fill that in our box above as so. Number of cubes needed to cover the bottom, we said was 32. Number of cubes in the tallest stack, 5. Total number of cubes needed to fill the box, 160. I'm going to do one more with you to make sure you understand what you're doing. So the next one, how many cubes to cover the bottom? Well, to cover the bottom, I had to count across. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 again. Then how many back did I have to go? Let's see, I got 1, 2, 3, 4, and then 1 underneath this one, 5. So I'm doing 8 times 5. So to cover the bottom, it's going to take me 40 cubes. What's my tallest stack? Well, there's 1 underneath here, so 1, 2, 3, 4, 5, 6, 7. What is 40 times 7? Well, 4 times 7 is 28, and I have 1 0, so it's going to take me 280 to fill the box. Go ahead and finish the rest of them on this page, and then again, check your answers in the answer key. Remember that geometric solids, such as those pictured on journal pages 300 and 301, are called rectangular prisms. The properties of rectangular prisms. Well, a rectangular prism has 6 rectangular faces, 12 edges, and 8 corners. The pairs of opposite faces are congruent. Any face of a rectangular prism can be designated as the base of the prism. The height of the prism is the distance between the base and the face opposite the base. So again, let's take a look at formula for the volume of a rectangular prism. Well, the formula, how would we write it, is volume equals the base times the height. But you're actually multiplying how many boxes go across the front, how deep they are, and then how high they go. So in box 3, we count 1, 2, 3, 4, 5, 6. So I have 6. Sorry for my writing. Times how many back? Well, here's 1, 2, 3, 4 that go back. And then how high? 1, 2, 3, 4. That's how I'm going to figure it out. So 6 times 4, I know, is 24. But I still have to times it by 4. 4 times 4 is 16, carry a 1. And 4 times 2 is 8, plus 1 is 96. So look for a pattern in the table on journal page 300. What do you notice? Hopefully, to find the total number of cubes needed to fill each box, you have to multiply the number of cubes needed to cover the bottom of the box. So again, covering this complete area by the number of cubes in the tallest stack. So going up to the top. You need to remember and pay attention to that the number of cubes needed to cover the bottom of the box is the same as the number of squares needed to cover the base. That is, the area of the base of the box. The number of the cubes in the tallest stack is the same as the height of the box. Therefore, you can find the volume of a rectangular prism by multiplying the area of a base by the height of the prism. So volume of a rectangular prism equals the area of base times height. We write that as V equals B times H. V stands for volume, B for the area of the base, and H for the height. Record this formula at the bottom of journal page 301. Alright, cube stacking problems. I'm going to do a couple of the harder ones with you because I know you can figure out the easier ones on yourself. When we're looking at what you see here as number 3, this one can be a little tricky. You first need to get taken care of this bottom layer, this base. So I have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's 11. How deep is it? 1, 2. What's the height of this layer? I am looking simply at this layer right here. Well, it's only 1 high. So I know 11 times 2 is 22, times 1 is still 22. But I'm not done because there are these shapes that sit on top of my base of 22. And since these 3 are the same size, I can simply go